you're coming in from. Well, my name is Vikas, and I'm one of the marketing manager with Kellton Tech. Before we get started with the today's session, let me just briefly introduce about Kellton Tech. We have been in the industry for and started in 1993 and 2017. It's been a long journey for us, and right now, if you see, we have an $100 million company servicing about close to 700 plus customers across the globe. Most of them coming in from the English countries, US, and the European market. Out of which, even we have also served 40 plus customers, Fortune 1000 customers on different technologies with a thought leadership and subject matter expertise in the areas of SOHA, BPM, APIs, and hybrid cloud architecture. We have been one of the strongest IBM practices featuring middleware products, IBM BPM, IIB, ESB, ODM, and web methods. For today's session, we are presenting DevOps by Chef, presented by Lakshmana Naina. He is one of the lead practice manager with us for last 12 years, carrying an experience in IBM WebSphere products like WebSphere Application Server, Portal Server, WebSphere MQ, and WBIMB. Just a bit of housekeeping before we get started. If you have any questions during the presentation, please type them into the question box on the GoToWebinar panel, and I'll bring them up during the presentation or end of the session. And however, also let me tell you that this call is being recorded, and the recording of this session will be forwarded back to you guys on your email address along with the presentation of today's webinar. So with much ado, let me just pass it down to Lakshmana. Lakshman, the floor is yours. Please go ahead and let's get started for today's session.
Sure. Thanks, Vikas. Thanks for your introduction. Thank you. So let's go to the DevOps. How you implement the DevOps and with the various tools, and how we can achieve the DevOps with automation tools. And we have done some case study at my client place, and that also I need to discuss. So how I achieve the DevOps. Okay. So I just want to talk about what is DevOps. Okay. The DevOps is a software development approach which involves the continuous development and continuous testing and continuous integration, continuous deployment, and continuous monitoring. And it will happen throughout the development life cycle. These activities are possible only in the DevOps and not in Agile or Waterfall methods. This is, where the top companies are adopting this DevOps because for reach their business goals. So before DevOps, most of the software organizations follow the Waterfall methodology. So in the software methodology, we have different phases of Waterfall model. That is, first it will start with the requirement gathering, system design, and system implementation, system testing, system deployment, and system maintenance. Yeah, in this, they were facing a lot of challenges while implementing this Waterfall methodology. So in the after development, the code deployment time was used, and the pressure of work on old and pending work and new code was high because of the development and the deployment time was high. On the other side, that on operations side also, it was not completely satisfied. There were 4 major challenges they were facing. Mainly, difficult to maintain the 100% uptime of the infrastructure, and the infrastructure automation is also not effective. And the number of servers monitoring also is a very complex and very tedious to maintain. So that's what we are having these challenges. These are the challenges while having the waterfall model methodology. So what are the solutions to provide to remediate the challenges of waterfall model? Mainly, the main solution for the challenge of the waterfall model is to enable the code deployment without any delay or wait time, and the work happens on the current code itself, and the development, the requirements makes it pieces and make the development into the sprint as short as and well planned. And coming to the operation point of view, the system should have at least 99% uptime, and the tools which are using to automate the infrastructure make effective, and the monitoring of the infrastructure and the feedback system should be there. So mainly it's a better collaboration between the development and the operation, and that is to make them transformation between the to make the requirements to transformation between the developers and the operations team. So these are the solutions for the waterfall methodology. So that's why these are the challenges which we are facing in waterfall methodology. That's why it leads to evaluate this DevOps. Okay, in the traditional waterfall model, the complete requirements are clear and fixed. The product definition is stable, but it takes a very longer time to promote that code into the production environment, and also it's a lot of time delay happening between the operations and the development team, and that causes that leads to the agile development model. And in agile development model, in agile development model, the requirements changes frequently in the development. They make the agility to the development and make it fast and rapid, and make the features in rapid ways. The next approach to both the approaches, which leads to the DevOps approach. Here also the requirements are changing frequently, and the development needs to be agile and the operation needs to be agile. The mainly DevOps evolved from the existing software development strategies, methodologies over the years in response to business needs. Mainly the waterfall methodology is a slow and cumbersome model. So that leads to evolve the agile methodology. With there we are the developments working on the software in short scripts, which is not more than 2 weeks, which takes the development not more than 2 weeks. Having such short releases cycle help the development team work on client feedback and incorporate it along with the bug fixes. Mainly in the agile methodology is the lack of collaboration between the developers and the operation engineers. That that still the development process and releases that still show the development and the operation engineers processes. Mainly DevOps, mainly DevOps is born from these two methodologies, mainly for better collaboration and faster delivery. and enables the continuous software delivery with less complex problems, and to fix the bugs and to fix the bugs which very faster, and provide the faster resolutions for the bug fixes. Mainly the DevOps model, it establishes a bridge between the software development and software development team and the operations team, and which is the transformation between these two, which helps to make the system better, and it avoids the it avoids the better system. And we're evolving into this the DevOps, mainly the business the business requirements is the most transformation between among all the team members in the DevOps implementation. So these are the challenges which was before DevOps implementation, mainly for when developers were using the DevOps waterfall methodology. The most waiting time for the code deployment, and the pressure of work on old and pending and new code. These are the challenges which were facing by the developers during when waterfall methodology was there. In the DevOps solution, and to provide a solution for this challenge is the continuous integration. The continuous integration, there is a quick deployment of the code, faster testing, and speedy feedback mechanism. And there is no waiting time to deploy the code, and the developer focuses on the current code. And the operations side, these are the difficulties was facing, the difficult to maintain the uptime of the production environment, and the tools which are automating infrastructure is not effective, and the service monitoring is a very critical, since it is not audited properly, and difficult to diagnose the feedback on the product. Mainly, when we are facing the uptime, to maintain the uptime of the production environment, and difficult. So mainly, there is a lot of cloud technologies. There are a lot of the cloud technologies available and in the market, and there is especially the container and virtualization ensures that it can spin up the environment with basic configurations, and it can make it available to the testers and the developers to test the code, and then they can promote the code to the production environment with by fixing all the bugs. And tools to automate the infrastructure management are not effective in the while adopting the waterfall methodology. In the DevOps, there was a solution for the configuration management. That helps you to the configuration management. As soon as the code is checked into the version control tools, from there the continuous integration will taking place, and from there it will trigger to the continuous configuration management and continuous deployment, and it will automatically spin up the environment and deploy the code, and from there it will be the testing will be automatically done and based upon the requirements, and from there it will promote to the code to the production environment. And the continuous monitoring also, after deploying to the code to the production environment, the continuous monitoring will be enabled on those environments. It will keep monitoring by, there various tools which is available. Like we are using the Tivoli monitoring and direct trace tools, which is enabled on production environments and the lower environments. So if any issues with the performance, it will be notified to the support guys, and that will make you know, and that will make to alert the and support guys to resolve the issues. And this is the DevOps lifecycle. So this is the DevOps lifecycle. In the DevOps lifecycle, in various stages, you know, in DevOps lifecycle there are various the various tools are using and on different stages for deploying in the for planning and for planning and since from planning and after doing the coding, there are various tools called GitHub and Jira or Eclipse are using these tools to do a coding. To do the build, there are you know, Maven and Gradle tools are using to do the build, and to do the testing for Selenium and JUnit will be using to do the automated testing, and you know, for releases they're using Jenkins and Bamboo, and monitoring there are various tools available like Tivoli monitoring, Nagios, and you know, Dynatrace, like that. And you know, for deploy, you know, Puppet, Chef, Ansible, and SaltStack. These are the tools are using in the various stages of the DevOps lifecycle. So you know, the DevOps lifecycle is broken down into the different stages. One is the continuous development, continuous integration, and continuous testing, continuous monitoring, and you know, making the virtualization and the containerization. These are the various stages of the you know, the DevOps life cycle, where you can achieve the where you can achieve the DevOps implementation by implementing all these stages. In the continuous development stage, the DevOps, you know, where the software is developed continuously, unlike the waterfall model. The software deliverables are broken down into the multiple sprints of short development cycles, developed and delivered in a very short time. This stage involves the coding and building phases and make use, you know, and this stage involves mainly for, you know, coding and building the building phases and make use tools like, you know, GitHub and SVN for maintaining the different versions of the code. And for building, you know, the tools like Ant, Maven, and Gradle for building and packaging the code into the executable file that can be forwarded to the QS for testing. You know, after it comes to the continuous testing, you know, as soon as the code is developed, and it will be putting into the GitHub, and from the GitHub, you know, after that, the GitHub will and the Jenkins knows that, you know, here the continuous integration we are using a tool called, to enable the continuous integration, we are using a tool that there are some tools available like Jenkins. And you know, in this stage, you know, where the in this stage, you know, as soon as the code is developed, it will putting into the once the code is developed with the new features, pushing into the GitHub. The continuous integration will be taking place after that, and it will pull the code from the GitHub and the code repository, and it will push it to the development, it will push it to the QS, and it will push it to the QA environment, and from there it automatically trigger, it automatically. So before pushing into the the test environments, it will automatically build by using different tools called Maven, Gradle, and Bliss, and to the using build and to convert into the executable files and deploying to the corresponding environment. There we can the continuous integration will be taking place. And before deploy the code, and it using some tools like to scan the code, and to as per the standards of the organization, and also it will do the, there are options to do the security scan, to more to more as to more standards of to follow the more standards of the organization. In continuous testing, as soon as the code is triggered, deploying to the test environment or UAT environment, after that, the continuous testing will be taking place. In continuous testing, where there are tools like Selenium and some other tools like JUnit will be using at this stage. What will happen is, after the deployment happens, it automatically triggers kick up the code for testing. It automatically tested the application on the various environments. If anything goes wrong with the testing, and it will send immediate notification to the developer to fix that issue. In coming to the continuous monitoring, in this stage, all infrastructures are enabled with the continuous monitoring in the DevOps implementation. So if anything goes wrong with the infrastructure level or environment level or node level or any application level, it will immediately trigger a notification to the support guys, as well as the developers, and as well as the whoever the supports that particular project. It will trigger to everyone. But the mainly support guys will be triggered and will get alerted, and to find the solution, to provide the solution as early as first. And from there, if anything goes wrong with the user level, it will send a notification to the BAs and business analysts, and from there, it automatically, they forward the request to the developers. And if anything go, in continuous monitoring, whenever any issues happen, there are some tools called like Selenium monitoring or any Omnibus and Negios. What it will do is it will create incident tickets and assign to the particular group which is supporting to the particular application, and they will taken care after that, and they'll, based upon that issue, and the corresponding teams will be act upon that issues. And then the last stage is the virtualization and the containerization. In this stage, by using in this stage we can spin up the environment, and based upon the requirements, automatically, and create the OS, spin up the OS environments. On top of that, create the applications and configurations and deploy the applications. All will be happening automatically by using the containerization virtualization. And this will be triggered by either Chef or Puppet or Ansible or SaltStack tools. So what are the main benefits for the DevOps? There are, we can say, the technical, if you can segregate the DevOps benefits, we have a technical benefits, the business benefits, and the cultural benefits. The main technical benefits is a continuous software delivery and less complexity to manage and faster resolution of problems. And coming to the business benefits, the faster delivery of features, a more stable operating environment, improved communications and collaborations between the developers and the developers and the operations team, and more time to innovate rather than fix and maintain. The cultural benefits here is the more productive teams and engaging, keep engaging the developers and the employee make happier to the employee engagement, and more professional development opportunities for in DevOps implementation. So this is the case study without DevOps. When Facebook was launched without DevOps, there are various, they were faced a lot of issues. To make the features available to the users. So the Facebook, when they were launching to use some features like timeline, ticker, and music functionality to its users, like they have in different zones, there are more than 500 million users, which is spread across the globe. They were facing, the huge traffic was generated on that topic, those Facebook following the release leads to the server meltdown, and the future was rolled out. So, I'm sorry, I was in mute. I have some issue. I'm sorry. This is the Facebook after implementing with the DevOps. There was a technique called the dark launching technique they used to, they're following a process to gradually rolling out the production ready features to select set of users before full releases. And the development team, that allows the development team to get user feedback early on test bugs, and also test. They're doing the test infrastructure and infrastructure performance, and the direct results of the continuous delivery. And this method, this method helps to release faster and more iterative releases that ensures that application performance does not get affected, and release is well received by the customers. The requirements, it's a iterative development and making into the short sprints, and they put these features into the one environment, and they keep they first test. If it works fine, then they move to the they move to the multiple environments and different zones to make their features available and across the globe. So using this continuous and continuous development and continuous testing and continuous monitoring and continuous integration and continuous deployment by using the various tools. So what is continuous deployment development? We can achieve the first phase of the DevOps. The continuous development. So in Git, one of the way you can achieve the continuous development, make the, by Agile methodology, one of the Agile methodology is a part of the DevOps implementation, which makes the, the business users will create a requirement, and it will make it as a small story. And the Scrum Master, the Scrum Master will provide some meetings and create a stories for each stories, and make them requirements to develop in less than 2 weeks. And as soon as the code is developed and they're putting into the GitHub, and where and the code will be automated and the code will be checked into the GitHub. And there we are maintaining the version controlling of the code, which supports the GitHub. Here the GitHub will be taken one of the tool called GitHub, which you can support the continuous development here. Mainly the GitHub is a distributed version control tool that supports the distributed non-linear workflows, and by providing the data assurance for developing the quality software. The main features of the GitHub is, it's a free and open source, and it's more speed and scalable and reliable, and it's more economical. And you can do the easy branching and distributed development. You can enable the distributed development and compatible with the existing system of the protocols. And mainly the GitHub, plays a vital role when it comes to managing the code. And that, when the collaborators, like developers, contribute to this as a shared repository. And this code can be extracted for the performing continuous integration to create a build and test it to the test server, eventually deploying to the production environment. The GitHub, which is which enables the communication between and the development and the operations team. When you are developing a large project with a huge number of collaborators, it's a very important to have a communication between the contributors while making a change in the project. And when you commit those codes in the GitHub, it's a play which will trigger to the operations team, says that it will be deployed into the particular environment, and they'll keep, of course the monitoring tools are available to monitor, but still the operations guys knows that there is a particular feature is deployed by using the deployed into the GitHub, so that it will be automatically deployed into the environment, so that they keep monitoring those features available or not by the support guys. So GitHub, GitHub, how it will be fit into the DevOps. How it will be fit into the DevOps, before continuous integration, the GitHub is before continuous integration, GitHub will be using as a meeting the source code of the new features and existing code. So next we'll go to the continuous integration. Here we're using as a Jenkins. In Jenkins, once the code is got checked in, and we can enable the code to build automatically by using the two ways. One is some organizations follow. Once the code got checked in, it will automatically go to the and production environment by enabling the nightly build and the continuous build. In nightly build means if they put a time at 12 o'clock, and the continuous integration, and in the continuous integration, the Jenkins will pick the code from the GitHub, and and it will build using some tools, and it will push the code into the production environment, and particular during off business hours. That is one way of building the nightly build. In the continuous integration, you keep sending as soon as the code is available and everything is tested, you can keep this code, you can push the code into the production continuously. So where is mainly the Jenkins is a part of Jenkins here, adopting the continuous integration, adopting the Jenkins tool to achieve the continuous integration. Here the DevOps use here the continuous integration is to integrate the various DevOps stages. In continuous integration, we can use it at the various stages, like before testing and before UAT environment and before production environment. As soon as the code is checked in, and it will be pulled by the Jenkins by using the GitHub plugin. Here before GitHub plugin, and it will put into the dev environment. And from there, it will execute the JUnit. It will trigger the JUnit to, for unit testing. From there, it will move to the next stage called the QA environment. And again, it will put the same code. And if anything, after the trigger the QA testing, if anything faces issue, if any find bug, if while testing it find any bugs, it will report to the developer and testers. Yeah, in continuous testing, and the continuous testing is a part of the DevOps implementation. Part of the DevOps implementation with the various in the various stages, the continuous integration will be involved, like in development environments and QA environments and UAT environments and integration environments and functional testing environments. There's various stages the continuous testing is involved, and once the code is checked in, the continual, it will be applied into the dev environment. From that, continuous testing will be picked up, and it will do the unit testing, and before moving to the QA environment, and after that it will do the QA testing, and after that, in QA testing we'll do the system, integration testing, and the functional testing, and the end-to-end testing, and in all this will be involved in a QA environment, and after that it will move to the UAT environment. There we have the business comes into the picture, and if anything, the user level testing will be done by using the continuous testing, and there, if anything goes wrong or anything goes, it will not match up to the requirements, it will send a notification to the business users, and from there, and they will assign to the developers. If everything got fixed, then only it will move to production environment. Here mainly, in the continuous testing, mainly supported by the Selenium, and here the Selenium is a tool which we can write automatic scripts by using Java. We can make it as a we can make this environment as a we can achieve the continuous testing by Selenium tools here. It's a continuous virtualization. So we can enable the continuous virtualization by by Chef tools, by tools called Chef or Puppet or Ansible or any Salt Stack. Here mainly, if the testers wants to test some applications, if they want to spin up a new environment, they can use this, and if you want to create the multiple environments with a span of less time, within a span of time, we can automate this, we can use a virtualization concept or a containerization concept or in a cloud environment, we can spin up the environments with with the various operating systems. We can spin up the environment with various operators, and we can create applications and configurations, and we can and by using this, in the stage of continuous virtualization and containerization. The virtualization is a technique of importing a guest operating system on top of the host operating system. We can create the multiple operating systems. In virtualization, we can create the multiple operating systems can run on the same machine, and maintenance and recovery are very easy in case of failure condition, and total cost of the ownership was so less. And if you can, in containerization, it is also a technique to bringing a virtualization of the operating system level. However, containerization is a more efficient because there is no guest OS here. It plays a host operating system. The main advantage of the containers is, it is the containers on the same OS kernel are lighter and smaller and with better resource utilization, and compared to the virtual machine. And this is the main difference where you can by using this diagram how the memory utilization by the virtual machines and the containerization machines. This is the last. This is the phase of the next phase is the continuous deployment. In continuous deployment, this fits after the continuous testing. It fits after the continuous testing. Here we can achieve we are achieving the continuous deployment by the Chef tool. Chef is an automatic tool that provides a way to define infrastructure code. Here the infrastructure as a code. We are treating as infrastructure as a code, and environment as a code, and in our environment. We have multiple environments. We have a dev environment and a QA environment, UA environment, and UAT environment. And each environment has a multiple servers, and so everything is defined as a code in the configuration file. And here we are using a Ruby to program the code, and domain-specific languages for writing the system configurations. Mainly the Chef here using is, Chef here using is the infrastructure configurations and application deployments and configurations which we can manage across the network. This is the chef architecture. The major components of the chef architecture is the workstation and chef server and chef node. In workstation is it's a small computer, and it's a simple computer which you can use with a local repository, and you can use a Mac tool to push the configuration to the chef server. And chef server is chef server. We can it is a centralized storage for the infrastructure configuration. In workstation, before pushing into the configurations to the chef server, this it will hold the workstation is the location from which all the chef configurations are managed, and this holds the configuration data that can be later pushed to the central chef server. And these configurations are tested in the workstation before pushing it to the chef server. And and the workstation consists of the command line tool is called a knife, and that is used to interact with the chef server and can be multiple, and interact with the nodes. And we can use the chef workstation to writing a cookbook and recipes, and you can those cookbooks and recipes you can and you can push into the chef server. And this is what the architecture, and the chef node is the chef node is like a WebSphere application server, IIB server, or a database server, or any TIBCO server, and it's a web server, whatever it is. We can treat it as a chef server, and and we can install we install the chef client on the chef nodes and each chef node, and by using the workstation, and after that you will federate the chef node to the workstation, so that it will pull the configurations based upon the metadata which is available on the chef node. And this is the master slave architecture of the chef, and between the master slave architecture for the chef servers and the chef clients. All in the workstation, all configurations are tested and pushed onto the server, and the nodes, and the server contains the cookbooks and recipes of all for all the nodes, which is maintaining the repository in the chef server, and the chef clients, which will pull all the configurations according to the based upon the policies defined in the metadata. This this slide is for the chef server, and now it checks us up for the configuration data, which stores cookbooks and policies. The policies we can apply to the nodes, and that and that describes the instructions for the node to for deployment. And the policies defined in the nodes mainly for deployments, or changing the configurations, or creating a logs archive, or anything, creating spinning up the environment, or creating, deploying, and undeploy the application. It can be anything, or you can execute the SQL files, or you can execute any bash scripts. So all will be defining in the policies. Here the main, mainly we are using the policies which we define for each node. We will write all the configurations in the recipes and cookbooks. And the cookbook is in which contains everything, um, uh, uh, cookbook is the group of recipes is called a cookbook, where each recipe has one. Each recipe has all the all the configuration details, and we have to instruct what has to do. And after moving the after removing the configurations to the each node, like recipe is a collection of resources that describes the configuration of a policy. The user writes a recipe where that discuss how Rackspace manages the application utilities like WAS, IID, rules engine, or Hadoop, how they are to be configured. Actually, Chef architecture follows the full configuration, and nodes are nodes are dynamically pull the configuration. The nodes are dynamically update the configurations in the server, which they pull the configurations from the server. It keep polling based upon the time. If you can schedule the node, each node. You can enable the node to enable every 5 minutes or every 1 hour based upon the requirement, and nodes will pull the configurations and it will run automatically on the Chef clients. Here, why I'm mentioning this diagram is the infrastructure as a code. I don't know, the slides are moving very slowly. See, here we are infrastructure. Here, every environment is treating as a code. We'll write a research for the development environment and staging environment and production environment. For example, if I want to deploy a standalone, I want to create a standalone environment, I will write a research saying that install the website application server and create a server, so create a JVMs, and after that and deploy the application on top of the JVMs and configure the databases and the queue configurations and JMS configurations, and all will be instructed in the recipe. And that will put and will make it as a recipe as part of the cookbook, and we'll push that code into the content, and we all will be developed into that workstation, and we'll put this into into the Chef server, and the node will be active. Node will be it will automatically it will poll the Chef server for every 5 minutes or every 1 hour, that depends, and it will if any configurations are finds different, and it will pull the configurations and it will spin up based upon the instructions mentioned in the recipe. Here also, here also we have we'll create a roles also. Every role has a code here. FI team has doing their own jobs, like they create a rules for how to load balancing the request and all, and they create a role for means if FI has one role, and when the user, the FI has a server, and based upon the user, it will find the role and it will create, the recipes will be invoked based upon the role. And the DB server has we are treating as a DB server as a role, and the app server as a role, and TIBCO server has its own role, or IID server has its own role, like that. This is how the Chef works. This instruction. This is the case study. This is the client's case study where I involved in the DevOps implementation. As in, we are using the multiple tools called Jenkins, GitHub, Fortify, Gradle, and Chef Server for continuous deployment, and Jenkins for continuous integration, and Selenium for continuous testing, and GitHub and Maven and Gradle are used for the continuous development. This is the actual architecture. This is the actual life cycle of the DevOps in our in our client environment. These are the tools, various tools we have at the DevOps stages. So how you implementing? I'm just mentioning the theoretical points how it happens, how we achieve the DevOps implementation. As soon as the code is checked into the GitHub, the Jenkins will pull the code from the GitHub and pull the code and it will use the Gradle or Maven tools to build the executable files, and it can be configured to run with every check-in, or we can move overnight, or based upon the developers needed and based upon the the testers needed. Once the year file is created, it is uploaded to the Artifactory. Here, Artifactory is a JFrog tool we have used. After push the code into the Artifactory, and it will, the Chef client will, the Jenkins will create it will trigger a custom Chef script, which will update the year year information, or the bar file deployment information, and and the database or anything, database SQL scripts, and all this information will be updated into the databags. The databags, it is and the database contains the location of the ER file, where it is located in the Artifactory, and where it is the bar file. It's based upon the environment. In database, we can mention like that. Based upon the environment. If it is a dev environment, where the location of the ER file in the Artifactory, and where it has to go, and what is the application name, all this information will be created by the Jenkins custom script. And also we have a YAML file which contains which is that is also developed by the developers. So, and that's mainly developers and the operations team involved and developed that YAML file, and where exactly in the YAML file, and where exactly has to download the ER or bar file or SQL scripts or J rules or whatever it may be, where exactly has to download and which server it has to go, and from there, and which JVM has to deploy, and which broker instance it has to deploy, and which port has to listen. All this information is mentioned in the YAML. And and the Chef client is configured to run every 5 minutes in dev and file, and where in other environments also. And it will download the YAML file, which is the latest one from the, download the YAML file from the Artifactory, and where the Chef client is exactly runs. It contains all the services, what all need to be deployed, and which service has to deploy, and which application JVM or which cluster and which broker instance. All this information contains in the YAML file. And the first, the Chef client will first it will check the any differences between the existing data bag, which is on the client node side, and the data bags which is existing on the Chef server side. If anything is different, and it will get the latest information from the data bag and put it in the Chef client side. And based on if anything makes a difference, like if any request comes from the GitHub says that I need a new deployment, those information will be present in the data bag, and like a new deployment for the bar file or any ER file or any SQL executions or any TUCO configurations or any whatever it may be, like any database configurations or queue creations, all will be present in the data bag. And if anything finds difference by the Chef client, it will trigger those configurations by using the recipe and create those configurations by using the recipe in the respective server. So this is what the this is what the YAML file looks like. Here we mentioned the this is the application name in the YAML file, and we have the artifact, and we have these are the ways we have to define the variables of the in the YAML file, and like what kind of application it is, and what type of application, and and where you have to download. All this information will be mentioned in the YAML file. This is what the example of the YAML file, and this is the recipe where we can, this is the sample code for the recipe which we have implemented at the, at the client side. And this is the recipe where how to deploy the application of ER file, and these are also the bar file deployment, how it is mentioned and all. This is the code we can use it in the recipe to deploy the bar file or ER file. And this is the data bag, this is the data bag information for ER deployments or the bar file deployments or for rules deployment or for anything. This is the sample data bag file where you have mentioned, as I said, where you have mentioned the environment names and host names and the cluster names and the location of the ER file where it is in the artifact tree, and all this information is mentioned in the data bag. So this is how the Chef server and the Chef nodes will be communicating with the Chef server by using this data bag file, by pulling the data bag file information and deploying automatically. So this is how we achieve the continuous deployment in our client environment by using the Chef tool. So this is the overall DevOps implementation. That's what I have experienced at my client side.
All right. Thanks, Lakshman. That was really interesting and good to learn about DevOps with Chef. Keeping our time in view, we have exceeded by 5 minutes, so we may not be able to take the questions at this point in time. So whatever the questions we have, we will consolidate everyone and we'll send it to Lakshman, get the answers back from him, and we'll send you the list of questions along with the answers and also the presentation with the video recording of this session. So you have been a wonderful audience today, and thank you very much for joining us. And also let me just take this opportunity to tell you that we are coming up with 2 more webinars. That's on March 7th, and the other one is on March 9th. However, both are into different platforms, but it would be great if you can, probably join us on the 7th of March for SAP GRC and March 9th on Web Methods 9.12. Once again, thank you very much. You have been an awesome audience. Happy weekend, and let's talk soon. Thank you. Good day, guys. Thank you, Lakshman.
Yeah, thanks, Vikas.